spoke it into existence, so consistent, no assistance. Hear me once, become addicted. If I rap it, then I live it. There's no cap when I be speaking. Listen, this ain't what you want, bitch. I'm a fucking phenomenon. What you want, bitch, I'm a fucking phenomenon.
Copy everything I'm doing and don't play around with it too much. Going to get a bit lost. I do recommend if you do end up breaking something and you're not sure where you went wrong, you can go back to the last available reference codes that I have in the app that's made for this tutorial, so you can always have some baseline working while following this. Anyways, so now that we have movement and our player, the next thing is to deal with the fact that we have some pixel art here, and it's really small, we can barely see it. So this is where we use interesting techniques. There are multiple ways to do this. Pygame has some built-in stuff for scaling, but you get a little bit more control if you do it yourself. And by do it yourself, I mean what I'm about to get into here. It's a bit slower performance-wise, but it's pretty much a non-issue at this resolution. So we can do self.display. Equals pygame.surface, and this is another conventional name that I just started using at some point. I think I got this, I don't know if I came up with display or what, I don't know where that came from, but for me screen's always been kind of the window surface, and then display is the one that I actually render onto. Alright, so we have these two surfaces. If you notice, display is half the resolution of the screen, and also I use a new function here, which is the pygame.surface function. And also I use a new, if you notice, display is half the resolution of the screen, and also I use a new function here, which is the pygame.surface function. Pygame.surface generates an empty surface, so like an empty image. It's like you loaded an image of this dimension using pygame.image to load, except it's all black by default. So just imagine a black image 320 by 240, and that's what pygame.surface does. This is useful for just creating stuff in memory that you might need for some kind of purpose. In my case, the display is going to be a second surface that we use for rendering. So the idea is to render onto the smaller display and then scale it up to the screen, so that you render on a small resolution and you scale it up, which creates the pixel art effect. So let's render everything onto this display. To do that, we just swap all this to the display. And then the last step right here, because the pixel art effect. So let's render everything onto this display. To do that, we just swap all this to the display. And then the last step right here, because actually I can show you what happens, you just get a black screen. Because now that we're running on the display instead of the screen, you get nothing. So we have to render onto the screen. The screen.blit and we want to put the display onto the screen. So if you do this, we now get this. So it's just shrunk. So the next step is to scale it. So this is also something new. We'll do pygame.transform.scale. In the first argument, is the surface you want to scale, and the second one is the new size. So what we'll do is self.screen.getSize. So we're scaling this surface to the size of this one. You could pass in like a tuple of any size you want, but it's convenient to just use the get size on the screen here. So the return value of this will be the scaled display. We can just throw it on the screen, and that's what we're looking for.
안녕하세요. 모션 그래픽 디자이너
Alright, so and now you can see the pixel art has gotten a bit bigger, and it actually looks like pixel. Alright, now this is where things start to get crazy. We're gonna get into tiles and physics. Well, we've already done a little bit of physics in the sense that we've implemented some code for velocity. We're not using it yet, but it is there. So we'll want to create a new tile map script. Tile map.py is what we'll call it. And in here we'll want to create
I just can't let you go. Lord knows that I've tried to.
a new tile map script. Tile map.py is what
the only one. No one likes being lied to.
we'll call it is there. So we'll want to create a new tile map script. Tile map.py using it yet, but it is.
Now I wanna burn all the bridges between us. I can't focus.
Is there. So we'll want to create a new tile map script. Tile map.py
Been thinking too much lately. I just need to clear my
is what we'll call it. And in here we'll want to create a new class. We'll call it tile map def init. And then we'll want to take like a tile size, we'll say 16, and that 16 is a default value. We'll say our tile size is equal to tile size, self.tilemap equals that, and self.grid tiles equals.
and we may have some history, but we don't have to repeat it. You made this mess and left me with the pieces. Now I'm gonna burn all the bridges between us. I can't focus, I can't forget. I've been thinking too much lately. I just need to clear my head. 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 I just need to. I just need to clear my head. I just need to. I just need to clear my head. I just need to. I just need to clear my head. I just need to. I just need to clear
This. Alright, so what we're doing here is we want two systems of tiles. So we have the tile map, which is where every single tile is on a grid, so just a square grid of a bunch of tiles. And then the off-grid tiles are things that we placed all over the place that might not line up with the grid. So the idea is that you can only handle physics with this grid here. It's more convenient to work with. You could add a physics here if you wanted, but if you keep stuff on a grid, it's easier to optimize it. So we'll have most of our tiles on this grid in here. And so there's a reason why this one's a dictionary and this one's a list though. So we're going to do something where we map each tile based on its location. If you've done any of this stuff before, you may have seen like an example of a map where you do, say, there's a little hill or something. So if you have a little hill you're mapping, maybe you would do something like this, where you have 3 rows in a list, and your ones represent the ground. So you get a little hill of the ones right.
Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't
here, and there's a slight issue with this approach. Let's say you wanted two islands that are far apart. You have to fill in the space between those islands with air. So if a lot of your world is air, you're going to have a lot of wasted space in your setup here. And you also have to go through all of the work of creating that space between the tiles as well. So the approach that I like to use instead of just throwing things into a list, because you can't have two elements at different locations without having all of the elements between. The technique I like to use is to create something where you have, let's say, a tile at the location 0 called +909. So this is location. We'll be using a slightly different strategy here.
Just like a spark that's breaking out. Can't make a stop, can't turn back now. We know that there's no room for doubt. No, we can't turn back now. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we gonna light it up tonight. We gonna light it up, baby. Tonight we gonna light it up just like the sunrise. We gonna light it up.
Here, you can use tuples like this as your location for your tiles, but I will be writing these as strings, so I'll use like 0, 0 or zero, 1 and stuff like that, and that's because of the way that files will get saved. I'll get to that in, I don't know, maybe an hour, but it's a lot easier for this use case to do it as strings because the format we're going to save these in doesn't support tuples. In my own framework, I added a system where I can convert tuples into something else so I can work with tuples because they are easier to work with in terms of the actual code, but I don't want to mess with the export stuff. Alright, so let's throw in some basic tiles for us to work with. We can do for I in range 10, and we'll create a couple different tiles. So self.tilemap string of 3 plus I plus 10 equals type, and we're going to get it a little bit more complex with that tiles here. Type graph variant 1 position 3 plus I 10. So there's a couple things to note here. First of all, our tile will now be represented as this dictionary. So that way our tile can have multiple attributes. You can implement this as an object if you wanted, and you can do like a tile like that. But I'm not going to go through all that effort. So we're just going to use the dictionary. The dictionary will have the type, the variant. So within grass, there's a few different types of grass tiles, depending on like what directions are air and stuff like that. And then I'm also storing the position in here, and that's because this position as a string is not easily usable because you would have to split it by the semicolon, convert it to an integer and stuff like that. So leaving 1 in here.
I prayed for you and kept you near in hopes you'd chase away my fears. I'm on my own, you made it so, and now I'm chasing nightmares. I used to run with you through the great big leaves, laugh at you when you laugh at me. Hope for us because I believe the home was just you and me. I thought you were the one for me. No point in blaming you, you did not know.
Here that's actually as a tuple of integers is easier to work with and actually faster. So that's useful to leave there. We'll be using that later. And then this is just concatenating the dynamic location based on the iteration with a fixed position of 10. So this is going to be the positions of 3 through 12 on the X and then 10 on the Y. So this will be a horizontal line of graph tiles. Alright, so let's copy this and we'll do it again, but we want a horizontal one. So for that, we can delete this, there's semicolon. And on the other side, and do cluster I plus 5, and then instead of grass, we'll take stone. And then this position needs to be updated. The position here should match the one here. So we do 10 by plus I. Or rather, I plus 5. And then we can, actually this one's inconsistent, so we do five plus I over here. Alright, so we now have our tiles, but we need a way to render them. In order to render our tiles, we'll need something to render. So we'll have to go over to our utils and create a function for our tiles. We'll need something to render. So we'll have to go over to our utils. And create a function for loading multiple tiles at once, because if you look over here in our data and we go to images,
I'm someone to be saved, someone to clean up and tame. Oh, some things never change, never
tiles, let's say grass. There's a bunch of images here. We don't want to type all of those out. We want that to load automatically. In reality, you could create a function to just load every single image in that directory automatically, which is what I normally do in my games, but we'll just be handling a single folder for now, and then we'll just load all those individual folders. Alright, so we can create a def load images function, give it a path, do images equals that, for image name, and then we'll have to import a new library here, and do import OS. So this is all we're going to do here is do os.list dir. We'll take the base image path plus path, and then I'll pass here for now. So OSSet lister will take a path and give you all of the files that are in that path. So specifically here, if we ask for, say, images, tiles, and we do grass, it'll give us the 0 through 8 images. This is a way to easily dynamically load images. So let's go ahead and say images, append, and then we can actually use our other function here, load image, and we give it the path plus slash, and then plus image name. So remember,
change my ways, leaving crumpled bodies in my wakes where I didn't mean to make them break, but they're so delicate and so mundane, and they keep coming like a moth to a flame. Oh, some things never change, never change. You'll break your back to make me feel again, suffocate to make me breathe again, lose your mind from endless pain. Some things never change, oh, redemption.
this is the path to the folder, but not including the base image path. That's why we don't have to add it again here, because this also includes it. So yeah, this is the path to the folder. We add a slash because we want to get something inside that folder, and we do the image name, which is given by this function here. Alright, so since this will return the loaded image, this images list will become a list of all of our loaded images. So we can just return that, and now we can use this to start loading some stuff. So let's go back over here into the game, and in our assets,
a couple milli now, I'm causing a commotion. I've been coasting, hear my name around the world like an explosion.
We are the apocalypse, and a path that keeps us floating. As we fly above the stars, the light won't scare us falling. So rise up, way too great to be landed. Rise up, way too great to be standing.
They never gonna stop us, fly by them like choppers, better took those risks, cold blood in my fists, we fire starters. One out of a million will reach those heights, always had a feeling that I won't deny that work, never could toss, look in my eyes, I'm on the rocks, rise.
this to start loading some stuff. So let's go back over here into the game, and in our assets we'll want to load a couple of things. So
so fast, all tied up like a captive. I want you. Used to pay my life, standing on rainbows, playing it cool.
just return that, and now we can use this to start loading some stuff. So let's go back over here into the game, and in our assets we'll want to load a couple of things. So We have several tile sets in here, or not several, but a few. Let's do decor, that's one of them. We'll do load images, tiles / decor. You could do this in a for loop if you wanted. Actually, we need a to import that up here. Also from utils. But yeah, we could do this as a for loop if you wanted, but since there's only 4 of them, I'm just gonna copy paste. So we have grass, we have large, decor, and we have stone. Alright. So let's take the grass, throw it over here, large decor, throw it over here, stone, throw it over here. Alright. So if I do that, and then if I just do print self.assets, we can actually see all of our assets if I run the game. Alright. So if you look in here, we have our assets. So you can see we have decor and it's got a list of a bunch of assets.
So cliche, I see the sparks you throw my way. I know your name is written on everyone's mind. Your whole show is captivating me, but don't think that I can see right through that disguise. But when you got close to me, you had me falling so hard, baby, yeah, now I get it. You got heads turning, and you don't even try. Well, would you look at that? My glass is empty, glass empty. How about I get another
Okay, just do
drink,
print
baby,
self.assets.
drink,
We can actually
baby.
see all of our
Okay,
assets
you got
if I run the game.
fire burning right there in your eyes. So when
And then
you
if I just do print self.assets, we can actually see all of our assets if I run the game. Alright, so if you look in here, we have our assets. So you can see we have decor and it's got a list of a bunch of assets, and these are just how pygame represents these surfaces if you print them out. So it lists all of the surfaces we have and all of our different tile sets, like grass right there. Alright, so now that we have those assets, we can start rendering our tile map. To do that, we do def render self surf
You had me falling so hard, baby, yeah, now I get it. You got heads turning, and you don't even try. Well, would you look at that? My glass is empty, How about I get another drink, baby, Okay, I get it. You got fire burning right there in your eyes. Oh yeah.
So that's our destination. And actually something else we'll want to take up here is probably the game. So we can do self.game. That way, can pull our assets. So
Lions roaring in the morning sun, searching for a longer day.
if you remember correctly, I mentioned that we have these tiles and these tiles. These ones are on the grid. These are the only ones I filled out for now. I'll get into these when I do the level editor later, but I'm going to write the renderer for both right here. So let's start with the stuff on grid, which is what we have working right now. We have for location in self.tilemap. So when you iterate over a dictionary, you'll get all of the keys. So that'll be these values. So we'll get like 3 and 310, for example. But to get the actual tile, we'll have to look it up in the dictionary based on the key. So that'll be self.tilemap location, and that'll give us this part. Alright, so from here, we can render it. So we can do surf.blit, and we'll do self.game.assets, and then this is where things get a bit...
Lions gonna come. The birds have just begun. We will always take a stand for the people, for the land. Let's go back.
bit tricky. We do tile type. So if you remember correctly, over here we gave these things names.
Let's go back to
Tile
trees were so
type.
kids across the land.
So if you remember,
Savannah, I'm coming home. Savannah, we'll never be alone. Savannah,
correctly, over here
the beauty of the world. Savannah, let's all take a ride.
we gave these things names. So in this dictionary we have, I'll do this print here. In this dictionary we have grass, and then it's a list. So if we go over here, remember we have grass, so we want to say we're looking for those images of the grass category, and variant will be the index of the image we want to use from there. So from here we can do another indexing on this asset. This thing. So this gets a little bit confusing. You can like print it out at this state if you want to see what you're looking at, but from here we can do tile variant to index based on this and get the very specific image that we're looking for. From here we can go ahead and handle the position for the rendering. So that's just going to be the position of tile, which we have up here already. And then something you have to do here is you have to multiply by the tile size, because these coordinates are in terms of the grid. So the grid has tiles of a specific size, and to get this in terms of pixels, because that's how rendering works, we'll have to convert it using the tile size. So self.tile size, and then we do tile position 1 by self.tile size. Alright, so that is a very long line of but it should cover all that we need for that rendering. Something else that I just remembered is that this might not work on for that rendering. Something else that I just remembered is that this might not work on Linux. This function right here behaves differently on different operating systems. I believe on Linux, the order of the files you get is different from Windows. On Windows, it's alphabetical. And it might be alphabetical on Linux in a different way, I forgot. But if you go over here, we're depending on the assumption that it'll load 0 as the first one and 8 as the last one. So that might not be the case. So what you have to do is if you just run this with sorted, it'll sort it for you, and then that makes it consistent in all operating systems. Something else you have to be careful about is that since we're depending on the file names,
Fire makes my city look so bright. Close your eyes and just stay tight. We have to go. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me while we leave. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me.
You just rather watch me fall from a quarter mile. I can see you at the call. Think about it, ring won't tell you what I saw. When you break it off, you'll see who had it all. You had it all. You said you wanted to fall into oblivion. Forget about the world we're living in. Fall into oblivion, oblivion. Oh, going into oblivion. Into oblivion. Forget about the world we're living in. Fall into oblivion, I'm going on. You can't fall asleep when you're counting stars. Got it together. Your mind can't sleep when you let it serve. Now you wanna see me fall from a quarter mile. I can see you at the call. Think about it, ring won't tell you what I saw. When you break it off, you'll see who had it all. You had it all. You said you wanted to fall into oblivion. Forget about the world we're living in. Fall into oblivion, oblivion. Oh, going into oblivion. Into oblivion. Forget about the world we're living in. Fall into oblivion, I'm going on.
So what you have to do is if you just run this through sorted, it'll sort it for you, and then that makes it consistent between all operating systems. Something else you have to be careful about is that since we're depending on the file names here, and it's alphabetical, 10 actually comes before 8 because it'll look at 1, 0 and it'll throw it either before or after the image number 1 because that's how it's sorted alphabetically. So the way you deal with that is you pad the front with zeros. So if you look at the entities here and say go to the idle animation, you can see I padded the front with zeros. That way 10 is no longer before 8. So that's how you can keep that.
Cashed in on my promises. You know I'm too generous. Now I've learned to never help you out. 'Cause I'm done cleaning up your mess. Found myself in my regrets. I've become a little stronger now. A little stronger now.
Consistent. This is abusing little. Bit of a trick to keep our images in order here. Anyways, so back to the tile map. The last step for rendering is to handle.
I can never ever find the right words, and there's no way this is real life. There's no telling you're the right girl, so I can only say that it feels right. It feels right. It feels right. Yeah, I can only say that it feels right. It feels right. It feels right. Yeah, I can only say that it feels right.
The off-grid tiles. These ones are going to be the same tile data, but they're not going to be organized the same way. So for tile in self.offGrid tiles. So this will be, for example, we could actually just dump this one in here and say that's an example of what we could have for the off-grid tiles. So it's just, we have that same type of tile object in there. It's just a list instead. The one thing to note that's going to be different is that this position will be interpreted as pixels instead of a grid position. And that's because, well, the whole point of this is to be able to put things off of the grid, whereas the tile map is supposed to be on the grid. So the coordinate system is going to be a bit different, so we don't have to do that multiplication with the tile size. So we just do surf.blit, and then we can grab the same thing right here, and then it'll just be the tile position, since that's already in pixels for this set of tiles. Alright, so we have our tile map, so let's go ahead and load it in. For that,
Always been a baller, know that you the one. I can feel it in my heart, yeah. I won't stop charging, we go and come harder. I can see you and I, way beyond the stars, girl. I can never ever find the right words, and there's no way this is real life. There's no telling you're the right girl, so I can only say that it feels right. It feels right. It feels right. It feels right.
So we have our tile map. So let's go ahead and load it in. For that, we can just do from scripts.
We show up in the party, flyer than everybody.
We show up in the party, flyer than everybody. We show up in the party, flyer than everybody. We show up in the party, flyer than everybody.
Dot load it in. All right.
Show up in the party.
All right, so we have our tile map. So let's go ahead and load it in. For that,
We show up in the party. We show up in the party.
we can just do from scripts.
We show up in the party, flyer than everybody.
We show up in the party, flyer than everybody.
We show up in the party, flyer than everybody.
We show up in the party.
We show up in the party. We show up in the party.
Dot tile map, import tile map, and then we can go dot tile map, import tile map, and then we can go over here and say our tile map is equal to that, and then just for the sake of it, we'll say that tile size is 16, even though that's already the default.
Kids screaming in the cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love every
Just because for clarity, you could change this if you want. So next step is to render it. In our case, we want the
It's hard to breathe, but that's alright. Hush.
tile map to be rendered behind the player, so we'll do self.tilemap.render, and then we went self.display is where it'll go. And something else I just thought about, speaking of layering, is that we probably want our off.
Can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids
Will go. And something else I just thought about, speaking of layering,
profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell.
is that we probably want our off-grid tiles to be behind the grid tiles, because in our use case, the things that we're going to be placing off of the grid are mostly decorations, and the things that are going to be on the grid are mostly going to be tiles you can like run into.
It's alright. Hush. content. Hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I want to taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out.
And physically collide with. So because of that, the decorations are normally something that go in the back. So you usually want to render these first if you're using this technique. So we can go over here and throw them right there so that they get rendered first, and that means that these tiles you collide with are in front. You don't want to be walking and you see like some sort of decoration, it blocks the view of a tile and you just run into something for unknown reason. So that should be good enough for now. Let's run it and see what we get. We got an error because I forgot to pass in the game. So we do self, that'll pass in the game reference so that it has access to the assets. And there we go, we have our tile map. And we can see our tiles, which look nice. So now let's make it so that the player can fall, because right now we can only move right and left. So for that, we go over here. And since later on we'll create a player entity that will inherit from this physics entity, but because gravity will be universally applied, I'll apply it to this physics entity object instead of creating the player one. So for now, the player can still be a physics entity. Alright, so let's go ahead and apply our gravity. These are normally something that go in the back, so you usually want to render these first if you're using this technique. So we can go over here and throw them right there so that they get rendered first. If you're using this technique, so we can go over here and throw them right there. So that they get rendered first. And that means that these tiles you collide with are in front. You don't want to be walking and you see like some sort of decoration, it blocks the view of a tile and you just run into something for unknown reason. So that should be good enough for now. Let's run it. See what we get. We got an error because I forgot to pass in the game. So we do self. Pass in the game reference so it has access to the assets. And there we go. We have our tile map, and we can see our tiles, which look nice. So now let's make it so that the player can fall, because right now we can only move right and left. So for that, we go over here, and since later on we'll create a player entity that will inherit from this physics entity.
the sky's falling down.
But because gravity will be universally applied, I'll apply it to this physics entity object instead of picking the player one. So for now, the player can still be a physics entity. Alright, so let's go ahead and apply our gravity. So to do that, as I mentioned, you apply acceleration by modifying velocity. So our velocity is going to be self. Velocity, and the y-axis of velocity is the second value. So right here, normally you could just do plus equals, say 0.5 or something, but I'm going to use a different trick because there's this idea of terminal velocity in physics. So in physics, something will have a maximum velocity it can reach while it's falling, and that's called terminal velocity. You don't want to just fall a long distance and just accelerate to an infinity because you keep falling. So for that, you usually want to cap how fast you can fall after a certain point. You want it to kind of ease into that fall, but you also want a cap. So for that, you can use the min function, which is a built-in Python function. It'll take the lower of two values, or however many values you give it. Let's do 5, that'll be our maximum velocity. Velocity downwards. Remember, since this isn't the normal coordinate system from math, we have positive y is down, not up. So that might be a bit misleading, but that's how it works. So this 5 represents a maximum velocity of 5 downwards. You can go more than 5 upwards, which would be like -10 or something. So that doesn't affect this. So we take 5 and then we do self.velocity 1 plus 0.1. So right. Here we're modifying the velocity, and then if this modified velocity is less than 5, it'll take this part. So that's just effectively doing a self.velocity 1 plus equals 0.1 if that's the case. But in the event that this number is smaller, it'll take this one instead so that it can't go over 5. I'll use this technique a lot later on, but I figured I'd explain it now since it going to drop this below the movement, and then now if we run the game, look at that, I'm actually going to drop this below the movement, and then now we run the game. Being updated. I'm actually going to drop this below the movement, and then now if we run the game, look at that, our player falls. But he falls through the floor. So and then now if we run the game, look at that, our player falls. But he falls through the floor. So now is the time for physics. This can be a bit tricky if you don't consistent between all operating systems. Something else you have in Acro, and it'll alphabetical will keep our image tiles. These ones are way. It's interpreted to be able to assist this. For that, we can just do from scripts.tilemap. Alright, so we have our tile map, so let's go ahead and load it in. For that, we can just do from scripts.tilemap, import tilemap, and then we can go over here and say our tile map is equal to that, and then just for the sake of it, we'll say that tile size is 16, even though that's already the default. Just because for clarity, you can change it if you want. So next step is to render it. So in our case, we want the tile map to be rendered behind the player, so we'll do self.tilemap.render, and then we want self.display is where it'll go. Next be render and map, import tile map to have our tile map. So let's go ahead and load it in. For that, we can just do from scripts.tilemap, import tilemap, and then we can go over here and say our tilemap is equal to that, and then just for the sake of it, we'll say that tile size is 16, even though that's already the default. Just because for clarity, you can change it if you want. So next step is to render it. In our case, we want the tile map to be rendered behind the player, so we'll do self.tilemap.render, and then we want self.display is where it'll go. And something else I just thought about, speaking of layering, is that we probably want our off-grid tiles to be behind the grid tiles, because in our use case, the things that we're going to be placing off of the grid are mostly decorations, and the things that are going to be on the grid are mostly going to be tiles you can like run into and physically collide with. So because of that, the decorations are normally something that go in the back. So you usually want to render these first if you're using this technique. So we can go over here and throw them right there so that they get rendered first, and that means that these tiles will collide with them in front. You don't want to be walking and you see like some sort of decoration that blocks the view of a tile and you just run into something for unknown reason. So that should be good enough for now. Let's run it and see what we get. We got an error because I forgot to pass in the game. So we do self. That'll pass in the game reference so that it has access to the assets. And there we go. We have our tile map. And we can see our tiles, which look nice. So now let's make it so that the player can fall, because right now we can only move right and left. So for that, we go over here. And since later on we'll create a player entity that will inherit from this physics entity, but because gravity will be universally applied, I'll apply it to this physics entity object instead of creating the player one. So for now, the player can still be a physics entity. Alright, so let's go ahead and apply our gravity. So to do that, as I mentioned, you apply acceleration by modifying velocity. So our velocity is going to be self.velocity, and the y-axis of velocity is the second value. So right here, normally you could just do plus equals, say 0.5 or something, but I'm going to use a different trick because there's this idea of terminal velocity in physics. So in physics, something will have a maximum velocity it can reach while it's falling, and that's called terminal velocity. You don't want to just fall a long distance and just accelerate to an infinity because you keep falling. So for that, you usually want to cap how fast you can fall after a certain point. You want it to kind of ease into that fall, but you also want a cap. So for that, you can use the min function, which is a built-in Python function. It'll take the lower of two or however many values you give it. Let's do 5. That'll be our maximum velocity downwards. Remember, since this isn't the normal coordinate system from math, we have positive y is down, not up. So that might be a bit misleading, but that's how it works. So this 5 represents a maximum velocity of 5 downwards. You can go more than 5 upwards, which would be like -10 or something. So that doesn't affect us. So we take 5 and then we do self.velocity 1 plus 0.1. So right here, we're modifying the velocity, and then if this modified velocity is less than 5, it'll take this part. So that's just effective. We're doing a self.velocity 1 plus equals 0.1 if that's the case. But in the event that this number is smaller, it'll take this one instead so that it can't go over 5. I'll use this technique a lot later on, but I figured I'd explain it now since it's a very useful technique. Alright, so we have our velocity being updated. I'm actually going to drop this below the movement, and then now we run the game. Look at that, our play.
너와 나의 story 사랑이란 내게 과분한가 봐 네 곁에 있어도 baby I'm so lonely 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 'cause I'm just another girl 이 밤이 외로워 난 더는 견딜 수 없어 Goodbye 'cause I'm just another girl 너무나 외로워 지금 네 곁에 있어도 baby I'm
player falls, but he falls through the floor. So now is the time for physics. This can be a bit tricky if you don't know the actual technique for doing these types of collisions. I remember I spent like a year or so on game development, actually I think maybe a couple years before I heard about this technique, and I actually just found it in some example code somewhere. I don't even remember where I got it from. But trying to write your own stuff for this from scratch is a bit tricky if you don't happen to know the technique for having consistent collisions. All right, so in order to handle collisions efficiently, what we'll want is a way to look up tiles. So for physics, in the case of the player, since it's not very large, you just kind of want the tiles that are nearby the player, and then you can run the collisions from there. You don't want to look up all of the tiles and test them all for collision with the player, because we know the player's position, and we can look up the tiles based on position. So there's no reason to try to test all of those collisions at once if we can just look up the 9 tiles around the player. If the player were bigger and could collide with a larger area, you'd want to look up more tiles. So keep that in mind if you're doing your own stuff here. But in our case, we just need the 9 neighboring tiles and we can get some pretty good physics. So let's do neighbor offsets equals -1, 0. These are going to be the offsets from a given tile to get the 9 tiles around and including it. So -1, -1, 0, -1, 1, -1. -1, 1, 0, 0, 0, -1, 1, 0, 1, 1, 1. Alright, so these are just all of the combinations or all the permutations of -1 through 1. Actually, this should be offsets, not offset. So now we can write an interesting function. We can do def tiles around self position. So you pass in a pixel position. So remember, the grid tiles are not in pixels, so we'll have to do a bit of a trick here. So we'll have to convert this pixel position into a grid position. To do that, we can do tile location equals int position 0 self.tile size. So if you don't know what this double slash is, it's integer division. So it'll chop off the remainder so that you don't get, for example, if you divide 3 by 2, you don't get 1.5. You would get 1. And you might be wondering, if we're doing integer division already, why do we need?
나도 어플 이런 거 한번 만들어 보고 싶은데. 근데 어디서 배우지? 배우는데 돈 많이 들까? 이게 말이 돼?
Def tiles around self position. So you pass in a pixel position. So remember, the grid tiles are not in pixels, so we'll have to do a bit of a trick here. So we'll have to tile locations. So if you don't, so that you don't get, for example, if you divide 3 by 2, you don't get 1.5 in here, and that's, we'll still have the dot. We'll do indexing in a moment. So we saw it's converted to an integer. And you might be wondering, okay, so if we're already converting it to an integer, why can't we just chop off that extra slash and do normal division and then convert it to an integer? Well, the problem there is that integer truncates. It does not do proper integer conversion the same way that double slash does. So for example, they handle negative numbers differently. Let me pull up a terminal so you can see this. So let's say you have 3 divided by 2, you get 1. Let's say you have int 3 divided by 2, you also get 1. So that's expected. But let's say you have negative 3 divided by 2, you get negative 2. You do int negative 3 divided by 2, you get negative 1. They have different results. And that's because they handle negative numbers differently. So int will pretty much just chop off, like if you did negative 3 divided by 2, it'll pretty much just chop off that 0.5, which is not a consistent behavior, because if you think about the number 0 through, actually negative 1, everything between, not including negative 1 and 1, so let's say 0.9, that will go to 0. Negative 0.9, that will also go to 0. So that's an important distinction, and this is why you need to be very careful about converting things to integers when dealing with computer graphics. This is making the space of 0 almost the size, or sorry, it's the same space between like 1 and 3. In terms of pixels, I guess, you could say that the 2 pixels bordering 0 get brought into 1 or something like that. It causes some issues when you're dealing with this stuff. So especially when you're dealing with grid, this mess of code will convert the pixel position into a grid position. So that's just the x-axis, so we have to do the y-axis now. And now we have both. We have a nice tile location, and then we can do a for loop. So for offset in neighbor offsets, this is the thing I defined earlier. We can now generate all of the tiles that are around this pixel position given. So for this, we can do check location is, and then we compose a string, because that's how we did our keys here. String of tile location 0, and then we do plus offset 0. So we're adding all of these numbers. To whatever this base location is, so that'll give the 9 tiles in that area. So So we do that, and then we add our semicolon because that's what splits our location, and then we can do it again, and we'll throw in that, which is the y-axis. All right, now that we have our string, we can do if check location is in self.tilemap. That just checks to make sure that there is a tile that happens to actually be there, because remember, in a tile map we can have a lot of empty space, and that's just denoted as there not being anything in the dictionary for that location. All right, if that location exists in the tile map, we can do, actually I'll throw a pass right here right now, and then we can go up here and we'll do tiles equals this. This is the tiles we're returning, so we can do tiles.append, and then we can just grab the tile data by doing self.tilemap and then check the location. All right, so now we can return the tiles, and this will give us all the tiles around that location. So I'm just gonna run this all the tiles around that location. So I'm just gonna run this function so you can see the output here. So let's just do print self. Player, actually no, self.tilemap.tiles around, and then we can do self.player.position. So that'll give us some interesting output here.
I need to find the best way to learn math and science.
It's brilliant.org.
You see that? So right when we pass to the ground, it started outputting this data here. So when we're in the air, it just gives us this, and when we're near the tiles, it gives us this. So this doesn't mean we're touching those tiles, it just means we're near them. And this is where we can actually do the collisions. Because that's a little bit touching this to the ground, it still gives us some interesting output here. You see that? So right when we pass to the ground, it started some sound function, so you can see the output here. So let's just do print self.player. Actually, no, self.tilemap.tiles around, and then we can do self.player.position. So that'll give us some interesting output here. You see that? So right when we pass to the ground, it started outputting this data here. So when we're in the air, it just gives us this. And then when we're near the tiles, it gives us this. So this doesn't mean we're touching those tiles, it just means we're near them. And this is where we can actually do the collisions, because that's a little bit slower than looking them up. All right, for the collisions, we got to go back to tile map, and there's something else we got to do, because we don't want to collide with all of the tiles. We want to be able to put stuff in the world that we can see, but we don't necessarily have physics for, so you can just like walk by a tree or something. So the next thing we have to do is add a function that'll filter the nearby tiles for things that have physics enabled. So let's do physics rex around. So we'll do another step in here to make the collisions easier, which is converting all of these tiles that have physics into pygame.rect. If you remember, that's what we did the collisions on, like, I don't know, an hour ago. So we can do rex equals this. This is the rectangles we're returning. And then we can use this function here to get all the nearby tiles. So we can do for tile in self dot, and then we do that and get rid of that self. And now we're iterating over all of the nearby tiles. If there are none, this whole loop gets skipped to begin with. So we would just return this empty list of recs. So if tile type, and this is where we're going to get into something interesting, we need to add a list of This is where we're going to get into something interesting. We need to add a list of things we want physics on. So physics tiles equals and I'll say grass and stone. So if you don't know, even though curly braces are normally for dictionaries, if you don't do the key value pair thing, this is what's called a set. A set is used for a collection of values. Usually order is not important, but the big thing is that no duplicates are allowed, and actually looking up to see if a value is in a set is more efficient than looking up a value to see if it's in a list, for example. So this is actually slower than doing this if you're looking to see if a value is in there. So for something that's being run a lot, which is checking tile, thing is that no duplicates are allowed, and actually looking up to see if a value is in a set is more efficient than looking up a value to see if it's in a list, for example. So this is actually slower than doing this if you're looking to see if a value is in there. So for something that's being run a lot, which is checking tile types, it's good to have a set there. And this is one of the techniques you can use to optimize things. And don't forget that we also have this code right here, which is also already a huge optimization. You can have as many tiles as you want, and the collisions will still run fast because it just looks up the nearby tiles. If you don't know, looking up a value in a dictionary is also very fast. You can have as many values as you want, and it still roughly takes the same amount of time to look up a value as long as you know the key. All right, so we want to check if our tile type is in the physics tiles. So if it's in physics tiles, that's very English, then we know that this tile that we have near us is a tile that we can collide with. So because of that, we now want to add something to our rects list. So we just do a dot append, and up here we're going to have to import pygame so we can actually create a rect. Do a dot append, and up here we're going to have to import pygame so we can actually create a rect. We can do pygame dot rect. We can do pygame dot rect, so a new rectangle. And remember, rects are just kind of a thing in memory unless you decide to draw them, but you can run collisions on them, you can draw them, you can do lots of stuff with them. So we'll create it with the x position being the tile's position on the x-axis, and you have to multiply it by the tile size to get the position in pixels, and then tile position on the y-axis. Get the pixel position, and then we also need the tile size because this will be the size of the tile in width and height. And since they're square, it's going to be the same for both of them. All right, so that will add the new rectangle. So we can return these rects. And if I go over here, and if